weekly exercise answers, right?
He did along with the Zoom videos.
I always wonder when the record in progress comes up, if anybody hits the leave meeting.
My habit is to turn off the video. That's my habit.
All right. So let's see, Gopal, where do we want to go?
Number 3, I believe, like that's like I have some weird numbers in the table.
Well, okay, actually, question. What are the weird numbers you're getting? Are they all the same?
Yes, like
Okay.
from all the
Right.
way down, like it's just same number, like each column has same, like different number, but all the way they are same.
So check this. I had a similar thing on one of these problems where I literally every value was exactly the same. And I tried it every which way, couldn't get it to be different. I finally went and asked him, and it is under formula. Yeah. Okay. So if you go to formula, calculation options,
Just hold on.
check your settings here. So what I understand this is like when it recalculates or how it calculates, and mine was on except for data tables. And if it's on except for data tables, you'll get like weird results.
No, mine is on automatic.
It's on
right?
automatic. Okay. All right. Well, that was the easy fix.
Hey, Matt, did you notice by looking, I went through the whole thing, and then I looked at the answers provided by him, and he added another table called overbooked customers, where he
Oh,
added
really?
another
On-
two-way table on that particular exercise.
On this one?
Yeah.
Oh, I did see like he had something off to the side, but I figured he didn't ask a question
I
about
don't
it,
think
so
that's
I go.
I don't think that's required.
Yeah.
But
Because like
it will be interesting to examine Gopal's Excel file and see what went wrong.
Yeah.
So, hey,
You-
Matt, we got a request from Carlos.
Yeah.
So we know it might be fun to do is do a overbooked customer data table, because it mimics the net revenue one.
overbooked data table.
Because you're basically, let me show you what I'm talking about here.
Yep. Go for it.
Overbooked data table.
Oh, gotcha. So basically, just for the different reservation limits.
Right. So here, the cell that you're looking for is overbooked customers.
Yep.
All right, back to you,
Yeah.
brother.
Oh, okay.
Do you want me to show like what I'm getting?
Yeah.
Yeah, that's a good idea.
Yeah, that'll be easiest.
Let's see my screen.
Yep.
Yep. So
Yes.
yeah,
Oh,
this is
I know. Actually, I already know what it is.
okay.
Sid, you're gonna love this. It's because you're using Excel on a Mac.
Yeah.
Bum, bum. There you go. They don't like each other.
Okay.
Just kidding. Go for it.
Oh, that got me. Okay.
Yeah. So I think, see, this is what I have.
So the verticals are all okay. Gotcha.
Yeah, they all are same. See.
Okay, so probably but going from one reservation limit to the next, they are changing. So probably what it is you don't have the random numbers in there somewhere, because as you go down, you should get like it should change a little bit because it's randomizing it.
So where, like, see this.
Yep, you got it there. Yep, in there.
So, and then this is the formula for cancellation, or
Yeah. All right, you want to go?
Oh
let's
no,
go
the
through and-
cancellation. The cancellation should be a random variable, right? Should based on a random variable.
No, the cancellations was because
It's a binomial.
it is not like
Yeah,
a
yeah.
percentage. It says like cancellation is 0.04%.
Yep. Yeah, but you have to do binomial
Yeah, binomial
equation.
invert. Yeah.
Yep.
Okay, so I might have missed it.
So do equals binom dot inv. Yeah, you should delete all
The cells are same?
no.
So let me do.
Oh, I see. You put a cancellation probability there. So binom invert. Yep, that one.
Okay,
And then
so
so the first one, so that's going to be your B15.
P15.
Yep. So that's the number of reservations made. And then the next one is your probability. So you can either put in 0.04 or reference that cell, whatever you want to do. Yep. And then the next one, do random.
Okay, so
Yep.
I think that's where I am.
Yeah, and then just close. Yep, there you go.
All right.
So what that does is the B15, because like that binomial formula wants to know how many like what's your like how many trials, and so you want to have that be the number of reservations made. So that's why you do B15, and then the probability, and then the alpha. That one I actually didn't really know what the alpha was. supposed to be, but he said do random. So
Okay, so let me run the data table again.
oh, actually, before you. Oh yeah, okay, go for it. Never mind.
Yeah. So
Will it redo it if you have all the data in there already?
I think it may. We
Okay.
try it out.
I've never tried it.
Yeah.
So my row input is going to be
The reservation limit.
reservation made. Yeah.
No, reservation limit.
Reservation limit.
Yeah, there you go.
Mhm.
And that's just a random blank cell.
So this is just a random blank.
Yep,
Okay.
there you go.
Got it.
Nice.
Nice. Thanks.
Sure.
So
I guess
I think Gopal may have just pointed at the wrong cell when pointed at the reservation
yeah,
made
I think
instead of
the last-
reservation limit.
I think the column, I didn't select the random one. I selected the cancellation.
Oh, that could have been it.
Okay. Yeah. that
Also,
could
it could have been that the cancellations wasn't randomized. So
Yeah.
you had the same cancellation every single time.
So
But
I
even
just-
still, the customer demand should have been different.
okay.
Okay.
Sounds good. All right. Giving control to you.
All right. What anything else on the exercise?
Oh man,
You were gonna-
I'm gonna have to watch that.
You were gonna create the overbooked customers table.
Oh, sure. Okay. So we can basically just copy this table. Let's go over here. Paste the values. And actually, you know what? We'll just paste the format too. And then delete all this. By the way, my Excel does weird stuff. It's like not super responsive. I don't know why it is. So if you see my mouse going weird, it's not because I don't know what I'm doing.
You have something called blue bean in your ribbon. That must be why.
Actually, it could be that Bluebeam takes up a ton of memory.
It's like an add-in, right? It's like an add-in. Usually you throw it off. Usually.
Yeah, Carlos knows about Bluebeam though, right, Carlos?
Blue beam.
I do. That thing always crashes.
Yeah, that means it sucks up a ton of memory. So Bluebeam is a PDF software that's specific to like engineering and construction industry.
Okay.
Also does CAD now.
Yeah. Yep. Okay, so what do we want to do with this one? We wanted to
No,
do.
you want to take U4, right? That cell U4, and you want to
Right.
put that under, that's gonna be now.
Oh, we're doing overbooked customers.
B19
Yeah. So overbooked customers.
equals, yeah.
And then we want these to be different. Actually, no, we don't.
No,
We want
that's
them to
all
be
the same. Yeah.
Yeah. Okay.
Just
Let's
run
get
it.
rid of this.
What if?
So row input will be still our reservation limit.
And then here's the tricky part, anywhere outside the cell for column.
And this is all formatted weird, so let's change this. There you go.
Are there any questions on this one?
Yeah, I mean, I still can't get that table, so I
Okay.
was hoping y'all could walk me through it.
Yeah. How far did you get?
I did everything but get that table. I just get a whole bunch of zeros.
Okay. Do you want to?
Carlos, yeah. Can you share? That would be much easier if you share, and then we can troubleshoot.
Yep.
Yes, sir. Give me a second. All right. So. Y'all can see? All right.
Yep.
Perfect. Yeah, I'm not really sure what I did wrong here.
Oh, you're doing the revenue table.
Yep.
Oh, okay, got it. So, okay, so in that,
Carlos, you didn't put anything on the
Yeah.
average, the blank one,
Yeah, it's
blank
not
cell.
linked. It's not linked to net revenue.
So this
so
right
go
here.
there. Yep, hit
Yeah.
equals,
Equals net revenue.
and then the B20. Yep,
Yeah.
that one.
Yeah.
Because what you're doing is you're basically telling the table to use the output from that cell as the
Okay.
input to that whole table.
Got it.
And what you can do too, so do this, select rows E through K,
And double click.
and then double click on the margin area, double click that.
Oh, there you go.
Yep.
All right. Well, that was easy. Thank you all.
Although,
Uh-oh.
no, your numbers are different. You're good.
Yeah.
Okay. Well, never mind. That was simple.
And then you just need the average on top. That's simple enough, I guess.
The average where? I'm sorry.
The average, like yeah, right there. Yeah, E3. You gotta do the average. Yeah.
Of what?
Of
The whole
Of the
all
column.
of the column.
I got to do the whole column.
Mhm.
Oh shit. Okay. All right. Well, I'll do that on my own time, so I don't waste
Yeah.
your guys' time.
Go to your reservation limit cell. Let's just see what the formulas are. Okay, oh, that's no formula. Go to the next one. Sorry. Okay. Okay, you got all those. All right.
Yep.
It just looked odd because it was like 310, 310, 310, 10, 300.
Oh, these guys. I think these were hard pressed. No, I mean this is what was on the
Yeah.
template.
Yeah. No, your data table is going to be based on what's at the top of the data table.
Gotcha.
Yep. Okay.
All right. Right on. Thank you.
That takes us to question number 4.
You have question 4? All right, see my screen?
No,
No?
it's still Carlos. I believe. No. Yeah. Yeah.
Good?
It's
Okay.
Yeah.
got wasn't connected.
What?
Oh,
Tao, you good? Okay. All right, number 4. What are we doing here? Oh yeah. Okay. So actually, I'm gonna delete this. This is so I copied what he had written on the screen. So if anybody does want this,
Yeah, I
this
did the
is
same thing
verbatim what he
too.
put. Yeah. Because I did my own, and then he started doing his, and like, I'm not sure I got it all. So I copied his and then came back and fixed mine after the fact.
Is it the same, by the way?
It is now.
Okay.
So I'm going to delete this before I
Oh.
upload it.
I just
gonna-
basically screenshot and then dropped it in my spreadsheet and said,
Yeah.
Okay.
So did everybody get this one, or do we want to go through it?
yeah, go through it.
Yeah, go
Okay.
through it.
All right, so let's see. This is blank, right? And then these are just input numbers, and then this is blank. Okay, so what we're doing here is, so this is, okay, let me just delete this stuff.
What are we doing?
So here we're basically saying, for each of these, this is how many of the components it takes. Right, so laser stop takes 18 component A's and 6 component B's. Speedbuster 12 and 8. So what we're going to do is figure out, okay, based on how many of these we're making, how many of each component are we using? So this is basically the sum product of the quantity of each of these product types that we're making and the number of components that each one uses.
Because I have unit profit as mine. Okay. But maybe I copied it wrong. Go on.
And then, so to do that, then we can just copy paste this down. All right. Good so far?
What did I do? Oh, wait. Yeah. Wait, why did I not get that?
Oh, your numbers might be different than mine.
Yeah, mine is like super small.
Okay, so let's just do this. Let's just start with 2 and 4. So if everybody puts 2 and 4, then all our numbers will match.
Perfect.
I see. 84 and 44. Oh yeah, okay.
Oh, good.
Oh crap. I think my baby's crying. I'll be back.
Okay. Wasn't sure what kind of all crap that was.
Don't worry, Raul. We got it recorded.
Yep. All right. So now we're calculating how many of component A and component B are getting used for the quantity of products that we're making. So then for profit, the same thing, some product of, I want to say this and this plus, might be a more clever way to do it, but this is how I did it. This and this.
So component A, comma, and then the first numbers, and then.
So in this, what I did, like I just did the sum product of the top table. I didn't account the components, because anyways your total profit is gonna be number of pieces you produce.
Actually, yeah, sorry. Yep, you're right.
So I just like some product of number produced and unit profit.
Yeah, it's this.
Yeah, and then unit profit. Yeah.
There you go. That looks better. Thanks. So now you got the total profit, right? So it's just the quantity of each product times the profit for each product.
Sorry, for H8, what was the formula? Is this just multiplying across?
Oh,
Or multiplying?
yeah, ignore this. Like you technically don't even need this.
Oh, okay.
But I'll show you what I did there in a second. It'll make sense when we come back to it. But ignore that
Oh,
for right now.
total profit was just
Yeah, can you total profit again? I'm sorry, I spaced out.
Yep.
So
So
product-
total profit is basically this times this plus this times this, because this is the
oh,
quantity.
another sum product.
So yeah, you can just use some product for it. Which now we know the shortcut, right? It's this.
Yep.
B5.
The key on the left of one.
Mhm.
Oh, why was mine so giant? T5, T6.
Yeah, you're using 2 and 4.
Yeah, I got 16,000. Why did I get 16,000? Hold on,
Alright.
let me try it again. Some product to, so laser stop, across. Oh, numbers
did it.
produced.
Yeah.
Oh, I see. Okay, yeah. That makes sense. Okay.
So what,
Oh,
hey,
shit.
Matt, where did you finally find out how to do the show all the formulas?
Oh, it's a control and then the trill key, which is the one to the left of one.
The trill.
There it goes.
Which,
Or
Sid,
I
you're
call
a
the
music guy.
approximation key.
What?
Is it-
Yeah, that's what
yeah,
I say.
true.
What do you say, Trill?
The trill key?
I usually say it like approximate.
Yeah. Sid, trill, isn't there a musical term that's trill or close to trill?
Yes,
Music
it's a,
guy. Yeah, okay, there you go.
usually using like wind instruments.
Hmm.
And also for the Star Trek people, it's a race of symbiotic beings.
Does everybody know Star Trek?
Hey, Matt, can you go on? I just need to see the formula for D9. D9.
B is a
D9?
boy or
Oh, there's no
D
formula.
is in dog. D is in dog.
No, there's no formula for it.
Yeah,
They're
that's,
just
B
numbers.
as in bog.
Dog.
yeah, that's
Oh.
this one. It's out right there.
Some product.
Yeah, so it's just the sum product of the.
Mm.
Yeah, it's some product of these two and these two.
Oh, okay, for the top. Okay.
Yep. Because all we're doing here is, so this is basically how, like, the total number of component A's used if we're building 2 of this product, which takes 18, and 4 of this product, which takes 12. So it's 2 times 18 plus 4 times 12.
The sum product.
Bueno?
Yep.
Moving on.
Cool. So, okay, so now we have our model, right?
Oh.
So now we go to our solver. And so this is what we put in. So we're solving, so our objective is to maximize profit, right? So set objective is going to be A12. And we're going to set it to maximum. And then the variables that we're going to change are going to be the number of each product. So that's these two right there. So we're asking solver to tell us how many of each of these should we make to maximize on product? Or, sorry,
What?
on profit.
What? That's crazy. I missed this. I didn't come to this lecture.
Oh, really? Okay. All right.
Can
This
you-
is,
No, it
This is
makes
gonna-
sense. I'm just like, that's kind of cool.
yeah, this is gonna blow your mind. This is when Excel starts to get like smarter than humans.
Can you enlarge your screen just a little bit, please? The solve, because
So I
I'm
don't know
having
if it'll
trouble reading
enlarge.
solve. Yeah.
I don't know if it'll enlarge the solver though. Yeah, it doesn't enlarge solver. That's what you wanted.
Maybe you can zoom through Zoom tool, like the one which comes on sharing screen.
Oh.
Is there a zoom or magnifier in it? No.
No. What
No,
does your
don't think so.
what does your constraint there? I can't really. Is it
Okay. Yep. So constraints. Oh, this is where somebody asked the question about changing, like making it easier to like follow what the cells actually meant. So I changed the cell name. So that's going to kind of throw this off a little bit.
So
The
what
result is the
cell
same.
name?
But,
So what is
So I
the
named
cell
one
name
of
in
this-
ours?
so that would be D8.
D8.
Yep. Because what I did is I went to D8 and I changed the cell name to component A total.
Got it.
So then it's just, so then when you reference that cell in the constraints, you can actually see, like, call it a name, right?
All right. All right. Back to the solver, please.
Okay, so the constraints basically, so like what we're doing here is we're saying we're gonna maximize on profit. And we
than
want to
or
know how
equal
many
to.
products. But our constraints are, this is the limitation on how many of component A and component B we have. So we put these limits in. So so Raul, the way we do this is, let me delete these. There we go. Okay, So we go in and we tell solver, we say, okay, so we go into solver and we say, okay, we're gonna maximize on profit. That's our objective, is to figure out what we want here. Set it to maximum. And then the variable cells, basically what we're telling solver to change is going to be our inputs, right? So we select those. So then we can just run it like this, and all it'll do is it'll probably come back saying each of these is in infinity, right?
Right.
But we say, well, we have some limitations because we only have 4,000 of component A and 3,500 of component B.
We have to set some constraints in there.
Yeah.
So down here, we
okay.
go add constraint, and it pulls this up. And so here we're going to say, so this is the sum of component A already.
Mhm.
So first one, we're going to say this, or it needs to be less than or equal to constraint. And since we have it in a cell, we can just put that there. So we're basically saying this
Oh.
can't go greater than
Right.
this.
Yeah.
And then we can just keep adding in more constraints, same way.
Got it. D8.
And then when we're done, we just hit OK. So now we have our constraints.
What?
And then
Cool.
the other thing that he said is, watch out for when non-negative needs to be a constraint, which is like don't have negative numbers. So here you can solve that by just hitting this. It just
Make constraint, unconstrained variables, non-negative. Okay.
And
Yeah.
then the second part is after you hit solve, you're gonna get a result, solve a result.
Yep.
And what you really wanted to say, keep that you solver found a solution.
Keep solver found. Keep solver solution.
There you go.
So that's there. The other thing
Yeah, yeah.
too is hit this little answer report
hmm
and go and turn.
Well,
okay.
what about return to solver parameters dialog or outline reports? You don't need
Oh,
that.
what that'll do is it'll revert back to that dialog box. So it's basically going backwards.
Oh, okay.
Yeah.
So I hit okay.
So now you should basically see this. It'll plug in the numbers here that gives you the best answer.
So
Was this the one that I?
so
asked
this one's
about?
saying like don't produce any laser stop.
Yep, and do 333.33 speed busters.
Yeah.
So what, one of the.
Freaking crazy. What is this?
And Matt, which one was the one where I was asking him, like, so do we need to mess with constraints and stuff until we get like the optimal model? And he was like, yeah, that's the whole point. Was it this one or was that another? I'm gonna go back look through the videos, but there was like, because he was saying, yeah, you can set this up and it'll solve it, but you need to be able to mess with it. That's the whole point. And I can't remember which one it was that we had.
Oh, I don't remember. Well, it was either 4, 5, or 6. It was one of those 3. Yeah.
All right.
So, where this report comes in handy is this kind of gives you a report out on what was found. So it shows that, so here's like the value that you found. That was where we started, which doesn't really matter so much. Our constraints that we put in. So it lists each constraint. And then it will tell you down here, sorry, that's the variable says the constraints are down here. It'll tell you which one's binding. And so what that means is that was basically the limitation, right?
Oh, binding means limitation.
Yep.
Okay.
So, and then slack is how much is left over, right? So what this is saying is the component A was the binding one. So we basically used up all of component A, but component B was non-binding and there was slack, there was leftover. So like when you go back here, you see, so component A, we used all 4,000 of them, but component B, we had a limit of 3,500, but we only used 26,666 and 2/3.
So if you were operations manager, what would you do differently?
That was probably when you asked that question. Yeah. So, and then, and that goes to the, why did I have this? I just did the slack
The
calculation.
slack
Here, which is
calculation.
basically just what's your limit minus how many did you use? So yeah, so Sid, as an operations manager, what would you do?
Well, I would see, yeah, that's a good question. You want to see whether or not you can move production around, right? That's the logical question.
Mm-hmm.
You know, but this is not going to be able to tell you. You know, it is. Can I make more of these, and how much it will affect my labor or product cost?
Yeah. So what if
it's kind of complicated? But what he's looking for is what would you do differently? Would you change the constraints? And that was what I was trying to get at. What constraints
Right.
would you change?
So let's just say, for the sake of argument, that we're a manufacturer and we purchase component A and component B from a supplier. Then what would you do?
Sorry, my children are screaming.
Say the question again, Matt.
So if you're a manufacturing entity and which we are, we make these Laser Stop and Speedbuster, and we're buying component A and component B from a supplier, and let's say this model is for 1 month's worth of production, and we're saying, okay, this is, here's what we did last month, and next month we need to buy more components from our suppliers. How many should we buy and put in our warehouse so that we have the components for the manufacturing team to build the product?
I
Well,
was
so
looking at it differently than that. I was looking about, can I move labor to manufacture more of component A, right?
Right. So
Move people or resources to.
yeah.
to
So
make
that would be like
higher
a different
profit.
scenario. Yeah. So that would be a different scenario where component A and component B are manufactured in-house, right? So we say like,
right.
we basically have like, okay, so let's play that one out. That's an interesting one. So we say we have a limited number of employees that make the components, and we can have them make component A or component B. And you can even go crazy by say they can make one component A or two component Bs or whatever you come up with. But so there it's in-house, and it's now, like to your point, says like, where are we putting our resources to make these? And you could say right here, well, we're constrained on component A, but not on component B. So we've got too many people focusing on making component B. So let's shift some of those over to make more component A's and
That's
balance
it
that
right
out.
there.
Yep.
That's it right there.
Yep.
And the other constraint you may have is that I only have a finite amount of inventory, so I can't really mess with it this month, but maybe next month.
Right. Well, and that's the other scenario where, we just outsource and we buy component A and component B. Then you say, hey, whoever our inventory manager is, you screwed up last month and you bought 3,500 of component A. You only needed 2,700.
Right. I took this, when you asked that question, what would I do differently? I'm looking at that numbers produced. How many did I produce? Am I manufacturing something, or am I putting something together? Am I like a Chinese, factory, and I'm putting together a
Right.
phone?
Right. Yep. The other thing too to do with this is like, you're making decisions to your product. So actually, here you go. Here's a fundamental takeaway from this. We can go back to our CEO and basically say, guess what? We can completely eliminate the Laser Stop product line. It's irrelevant. We don't need it. Because we can maximize profit by only selling Speedbuster.
Well, if that's the constraint, if the unit of purchase, the component A and B's constraint is there, yeah, then Speedbuster is the one to produce, and that should be the focus.
So
completely-
let's try that. So what if we do? So here's where you do another analysis, right?
Mhm.
So we say solver, run it again.
You made, yeah.
Boom, there it is again.
45,
So
up from 45.
yep.
I think it's as long as the mix of parts used from component A and B is the current mix, it will still give you the same result.
Right.
It will still give you the same. Well, basically, Laser Stop is nothing, and then Speedbuster is it's the maximum amount.
Right.
Yeah.
But your slack went down from 833 to 160.
Right. Well, this is, yeah, it actually, so Benny, your point, like this is a fairly simplistic view of it, because this doesn't take, like, the number of components used doesn't come into play in this, at least directly for this model. So, so it really is kind of a simple thing of like, well, if this is $136 and this is $124, it's always going to be build more of these.
Yep.
You make more product, or you make more money. And this uses less products overall, or components overall. All right. So we good on number 4?
Yep,
Yep.
thank you.
All right, so
Wild.
number 5. What do we have here? So this is empty, right? Or no, this is
Yeah, that was empty.
this is empty. This is
That's also empty.
That's empty. And then you have all this, and you have all this, and then this is empty.
That's correct.
Right. All right. So similar to the last one, these are your inputs. This is like how many what was this? Ship campus rules forces. Okay, yeah. So we've got, here's our 2 plants that produce product, and then we have these different places that they can go to. And so this is like how many is each plant producing to ship to any of the 4 cities, right? So you can just plug in starting numbers here, doesn't matter. This is what we're going to solve for. Then what we need to do to set up our model is we need to calculate how many, how much product are we doing from the Akron plant and how much from Evansville. And so basically each one of these here is just a sum of all of this. All right, so how much Akron does for Chicago, Cincinnati, Indianapolis, and Pittsburgh added together, that's the total that Akron has to produce. So this is just a sum of all that.
So you just put any values in there?
Yeah, you can start with
Yeah.
any values here.
Yeah,
Just-
it needs an integer in there.
yeah, we're gonna solve for it. You can leave it blank too, really, but having a number there to start with just kind of makes it easier to wrap your head around what we're doing.
Okay, so let me do that.
So you can do like 1, 2, 3, 4, 5, 6, 7, 8, 9.
I'm just gonna copy these for example. Cool. Cool.
Right. And then same thing here is we're going to calculate what's the total of product going to each city. Right.
So that's
this is
just a sum.
Yep, sum of the ones above it. Exactly. And then that's going to play into our limitations because outside of that, we have, these are all of our limits. So the weekly capacity for Akron is 3,500 and for Evansville is 4,000. And then similarly, the demand, so now this is like a lower limit, is 1,200, 2,000, 2,500, 1,400. So each of these cities has this lower limit of how much they need. So then that's our basic model with the limitations. And then down here, now we calculate what's our total cost. So this is the cost for each of those products for the location.
Shipping cost.
Yep. And then, so we're going to calculate the total there, which is a sum product. And it's kind of easy. You can just sum product this by this.
Oh, wow. Okay.
So it's kind of sum product is an awesome little tool. Like you can do a lot of math really fast with sum product.
So the objective
Got
is
it.
the objective is to find out what the cell B15 is gonna be, the total cost. That's our objective. When we
Yep.
run All right, I think you're ready to go with the solver, right?
Yep. Oops. Okay.
Oh, so that's what we're doing for these points here.
Yep. So basically,
Okay.
yeah. So we're going to use Solver to tell us how much do we need to ship to each of these cities from each plant
Given.
to stay within all these to stay within our total production limits, but then meet our demands at the lowest cost.
Ah, I
What's
see.
going on there?
Okay, so that's why it doesn't matter what points you put in to start.
Yeah,
because like you were essentially have to like meet the demand.
yeah, because
Yeah,
solver's
it's
gonna
solver.
solver's gonna replace all this anyways. So like what I have here, this was the end result from solver.
Got it. Oh, I see. Okay, so let me like change it then.
Oh, you can I mean, you can start at 0. It's gonna get replaced when you run solver.
I have different constraints in yours.
Got it.
You have different constraints.
Oh, that makes
Yeah.
sense now.
Oh,
Okay,
okay.
I only have 2.
let's see.
Oh, because
I
You
did a
did the-
range. I did a range. I did,
yeah,
B6 through E6.
yep.
And that's greater than or equal to B8 through E8.
Oh, so you have to do each one. Wait,
No,
these
I
six
did
pieces.
I did each one, but what Sid's saying is you can do them as a range. So here, let me-
And then the second criteria was
actually, I think I can reset.
F4, is that right? Yeah,
Oh,
All right, so
F4 is
do-
less than H4 range through H5.
so
Yeah.
set your objective, and this time hit minimum, right? Because we want to have the lowest cost.
right. Okay.
And then this is our range for our variable cells.
That's right. That's what was messed up. Okay.
And then for the constraints, so what Sid's saying is, so you can set, you
B6
set all of
through E6.
these have to be greater than or equal to
Right,
all of these.
bada bing.
And then these have to be less than or equal to these. So instead of doing each one individually, you can just do ranges.
Oh, I see. So, okay, so then
Less
the
confusing
second
for-
one
Yeah.
is B4 through E5.
Oh, this one here? Yeah,
Yeah, B4 to E5.
because
And then
that's
greater than-
this. Yep.
Yeah.
And by the way,
And then
Matt, I
greater than or
stole
equal
the-
to
I-
the capacity.
I stole the simple formulas here during class.
Mhm.
So these are his.
Huh. So I got like it says unequal number of cells in cell reference and constraint. Let's see.
Wait, you hit solve
For
already?
this, oh no, not yet.
Oh,
I
okay.
just hit cell reference. So B4 to E5,
Yep.
right?
Yep.
And
Yeah,
oh wait, no, in my constraints. I'm in my
Oh.
constraints. So
Oh,
what's
okay.
the? Oh, it would have to be like the Akron to the.
Well, you're just doing the totals because you've already calculated
Oh.
totals.
Right.
So
Okay. So I have B. Okay. So then I have B6. What do I have? What am I doing here? Let's see.
So basically you're saying these totals here, these have to be greater than or equal to these
Oh,
ones.
Ah,
Right.
okay. Yeah. I think that's what I.
So that's one of your
65.
constraints.
and then the second one is the.
Yep,
total.
I have that. And then what's
Okay.
the second one? Yeah.
So the second one is these ones have to be less than or equal
Oh,
to these
those.
ones.
Ah, that's where I was messed up. Okay. So it's this less than or equal to. So this one goes back to less than or. Oh, no, that's right. Okay. Okay. Let's see. Huh.
Getting a weird number.
No. Oh, yeah, well, I put all zeros. But even then,
You can rewatch
that-
it tomorrow, buddy.
I think it's better if you show your screen what you're doing.
oh, yeah. All
Yeah.
right. Let me just share my screen. Good call.
That'll work too.
Okay,
We lost.
so
No.
let's see.
We don't see it yet.
Oh, oops. There we go.
Got it.
Good. Okay.
Yep.
Okay,
All right,
so
so you got an answer.
yeah, I'm not, well, I had all these as zeros to begin with. Did I have to sum
Yeah,
this?
Yes.
Like I had to actually sum it. Okay, so like,
Oh,
here.
yeah, yep, yeah.
Yeah.
So that's the sum of the ones to the left.
right,
Yeah.
okay, so I had left that blank. Okay. Got it. Okay, I think that's where I messed up. Okay, and
Although the
so
weird thing
now.
was, I feel like it gave you the same numbers that I have.
Oh, what
No,
am I
no
doing?
regression for today.
Yeah,
The nice thing
Okay.
about solver is it keeps everything in there.
okay, so then here, so that,
So 12,
okay.
9, 11, 2500, 14. Yep,
that's right.
yep. I got
Does
the
he want to see
same.
our reports?
He didn't do it on his, so I'm guessing no, but
All right,
Huh,
you got the right
Oh,
answer,
okay.
buddy. You're fine.
perfect. All right, awesome.
Yeah.
Thank you. All right. Okay,
all right, let me know when it comes up.
so,
We'll go to 6.
so that's the minimum. We got it.
You see my screen yet?
Yeah, I think so. Yeah.
Are you on question 6?
All right, so question 6, we have, let's see, this is blank, right? And then I think all of
Yep.
this is blank. Okay, so basically what he was showing here is when you start to add in, like each one of these was just continuously more complicated set of constraints and parameters. And so we had like the limitations. So we've got that here. Now we've added in some new ones out here. So let's start. So this is basically, let's see, what were we doing here?
Hang on, I'm gonna give you the blank slate. So nothing in chosen, nothing in
Yep.
total cost.
Yep, I think these were all blank and then these were blank and then.
No,
that
no,
was
the
blank.
1,300,000,
Yeah.
that's,
Oh,
that's fine.
These
They
are
were
there.
there.
That one there. And he has 35 as a, also. I'm looking at the template, just download it.
Yeah,
All right, so take out the 1.
Yeah.
yeah, you can, I mean, you can plug any number you want in here as a start.
No.
This is what,
What I'm saying is in, from 14, right, total workforce, that one's blank.
yep. Well, this one too.
No, yeah, that one's 2, yeah,
Yeah, all these are blank
correct.
and that's blank. And then these are actually blank. Yeah, it's like that.
And then under 35, the 1s and 0 there.
Under 35. Oh, these ones?
Yeah,
Oh,
There you
yeah,
go.
okay, yep.
now you have a clean slate.
All right. So here, this is what we're solving for. So basically what we're saying is these are the different projects that we can take. This is the value of the product or project. This is how many engineers it takes for us to staff that project. And this is what our costs will be to take that project on. So what we're saying is like, how many of each different project do we want to take? That's basically what we're trying to figure out. So want to say, okay, well, and then we're gonna have some limitations here. So the first 2 limitations to focus on is our total costs. So we have a limit of $1.3 million. So we got like $1.3 million in the bank to fund these projects. And then we also have 35 engineers. So those are our limitations, right? So here, this is going to be the number of projects, and we want to sum all that up. And I don't remember why. I don't know if we actually need to sum it for whatever reason, but it's there. So let's add that in.
Bada bing.
Then I got a sum of that. So then we need to first set it up so that we can work with these limits, right? So we're going to say, so total cost. So we need to add in the calculation of total cost. So that's going to be sum product of the costs and how many of each project we're doing.
Yep.
So like if we say, hey, I'm going to do one of each of these. Oops. Oh my goodness.
Yep.
So then it's basically going to say, okay, well, I'm doing one of each of these. So it's going to sum all that up and gives me the total cost right there. Right.
Got it. Yeah.
So then similarly, we're doing the exact same thing for the workforce. So we're going to take, here's how many engineers, some product with how many of each project.
Oh, dude, I mean, I get it, but I don't. So it's weird.
Well, we're part of the unfair part here is we're skipping through the whole like reading the problem and like wrapping your head around, ultimately what we're trying to accomplish.
I'll circle back to that. This is good. This is good.
Once you read it, you're kind of like, all right, like then you see like, okay, I get what we're trying to accomplish here. Right now we're just like throwing numbers in. Okay, so you can actually do a solver based on this, right? And I think this is kind of the way he did it in class, right? He said like, all right, let's do this first. So then if you remove all of these constraints, let's reset the whole thing. So here's like no constraints. We're ignoring all this stuff down here. Oh, actually, wait a minute. We need the present value. So what's the total value of this? Right, so we need to calculate that. So that would be another sum product.
NPV plus chosen.
Yeah. And
It's here and that. So that's the value of the whole thing. All right. Good to go.
Yep.
Which is way more than, right?
Yeah. Well, because we haven't like put in any of the other limitations or even we're exceeding all these too.
Yeah.
So what we're ultimately going to do here is we're going to say, okay, we want to get the maximum value for the limited number of resources we have. So we're going to say our objective is the value. We want to maximize it. And what we're going to do is we're going to change the number of projects we're taking on. And right now we're going to do these first two constraints. So we're going to say with the first constraint being this, our total cost has to be less than or equal to the amount of money we got. And then we also need to.
Oh, the amount of money. Oh.
Yep.
This is nice that it's spelled out for us.
Yeah, I was gonna say like he really did us a solid by putting these in this way. It kind of takes the guesswork out a little.
Total workforce and okay, less than or equal to 13 million.
But you were on total workforce.
1.3. Yeah, total. Is that wait? Oh wait, I think I messed it up.
Yeah, so total cost.
Delete.
So look at this like this. So it's like total cost is calculating this has to be less than or equal to that.
Oh, I see. Okay.
So that's one constraint. And then the next one is total workforce. So this has to be less than or equal to that.
Oh, I see. Yeah.
All right.
So you can do this. This is where it started to take longer. Right, and then there you go. But so there's a few things here. One is we can't take 2.6388888889 of a project. Like these have to be solid numbers or whole numbers.
You call it integers.
Yep.
So it's just format.
So what we do, nope, because format, all it will do is change what you see. That decimal point will still exist. So what you do here is you come in and you add another constraint, and it was here. Oh, well, actually, so select the cells. So these ones here, right? And then the constraint is you go down here and say, actually,
integer.
Integer or binary?
Integer.
I think it was integer.
Oh no, here it's binary, right? Oh,
It's
no,
binary because it's either project selected
correct.
1 or not selected 0.
Yeah.
Correct.
It's
Actually, does it
binary.
say that in here?
No, it doesn't say, but that's what I Because you can only select one project at one time. Like you cannot select one project 3 times.
went really well. Yeah.
Is that what? So do we need to fix the at most 1 up and 2? Is that where, before we do this one?
Classmates are doing us a solid and kind of doing the lecture.
I did have binary in there when I did it the first time, but I'm not actually seeing in here that it says it's binary.
No, but if you choose integer, then
Oh,
you can get like one project for digit 3. So basically it says like you're gonna do this project 3 times.
Yeah,
That doesn't make sense.
yeah. Well, okay, fair. Yeah, yeah. And this is the way he did it in class anyways.
Yeah, so binary, that's
All right, so binary for that, right? So now when you run that, you'll actually get, so binary route. So those two constraints, integer will basically limit it to whole integers. Binary means it can only be 0 or 1. It like basically limits it from doing more than 1.
and then we have 2
Oh,
more.
you're muted. Raul, you're muted.
Damn it. Oh, why would
I
we?
did that to you for having a side comment.
Why would we want to do binary? Like, why do we want it to be 0 or 1 and not like how many of the projects we chose?
Well, that's what we were just discussing, and well, Paul's point, I think, nailed it, which is like, view this as these are the projects that are available. There's one of each of these, and we're deciding which ones we're going to take. There's not like an infinite number of each of these.
Oh, I
projects.
see. Oh,
It's
that makes sense.
you can view it this way, Raul. Like it's more of a yes or no. You know,
Yeah.
it's more
Yeah.
treated as a yes or no.
Okay.
And that's what the binary is. It's basically it's 1 and 0. Those are the only possible outcomes.
Got it. Got it. Okay. Thanks, guys. Yep.
So, okay, so now we got that, right? So now we stepped a little bit further into it. So then the last part is we've got these extra constraints, which he describes down here. And he spent a good bit of time talking about this, and it's actually read the question, wrap your head around it, and this actually becomes like a very clever way to like essentially program into this like other constraints that are more complicated. So the first one is now you can only select at most 1 out of project 1 and 2. So you can't select both, right? So like right now it's selecting both project 1 and 2, but the limitation is you can only do one of them. And then so similarly is if you select project 4, then you have to select project 2. So those are 2 new constraints. So the way to tackle these is you have to like do some clever programming to come up with a way to bake in these constraints so that at most 1 out of project 1 and 2, the way to accomplish this one is you basically sum up. He actually said, do you remember how he like mapped it out with like the decision matrix? That kind of, I think, was the best way to
Hang on
understand
a
it.
second. So
The
for
0 and 1. Right?
B16 is F4 plus F5.
Yeah, you're summing the 2. But like he had he was trying to do it like this way. So think about this. How do you set a constraint for this limitation? You can only do 1 out of project 1 and 2. You can't do both. But you have to set a constraint that's basically a mathematical formula so that it can go into the constraints. Like you can't like write into it, if you do 1, you can't do 2. And if you do 2, you can't do 1.
So what you're, okay, so in B16, you type in F4 plus F5.
Yeah. Well,
Yeah.
yeah. No, I was trying to explain like the logic behind, or like the understanding of why that is what it is.
Yes.
Oh, so Matt, I think it's like this. So if you in A26, you put project 1,
Yeah, no,
Mhm.
I got that. No, it's for Raul's benefit of trying to
Yeah.
the understanding of why.
No,
it's like this.
I remember how he displayed it. So it's so for example, like project 1, project 2, and then I think on the column is project 1, project 2 also.
So it's kind of like, what are the possible outcomes? So it's like,
Right.
you could do 0 of both.
0.
That's possible.
Right.
Oh,
Mhm.
that's right. The one,
Yeah.
0 and 1. And
1 0.
1,
Yeah.
but not 0 and 2.
Right.
Yeah,
But you can't do.
1 and 1.
Yeah, this is no bueno.
Yeah,
Why is it no
okay.
bueno?
Because you can only do one or the other,
Right.
at most one of them.
So now you're looking for, okay, what's a mathematical formula that can limit it to only these potential outcomes? And ultimately what it is like, think about it, what's the sum of those is 0.
Mhm.
Some of these is 1, some of those is 1, some of this is 2.
Right.
So if you basically take this and make this be the sum of these two, and then limit it to 1. Because if you limit it to
It
1,
has to
then
be
it
less
won't
than
allow this to
1.
happen.
Oh, I see. Okay.
Does that make sense? And it
Would you-
like you can test it out up here too, because right now we have project 1 and project 2. And so it's giving 2, but that's, this isn't satisfied. So once you go to change this, you're good. You can do this and this, you're good.
Oh, man. Hold on.
That, you're good.
Yeah, that's a good explanation. You got it.
And don't you love Excel? Right. Great. Excel's great. Mm.
All right, then.
Okay, I
4,
need,
then
can you really quick just click into, yeah, so I can see. Oh yeah, cool. Oh, that's what, okay. That can. And my constraint, oh, I see. Okay. All right. Yep. Good.
Cool.
Okay.
All right. So then the next one, and he basically gave us these 2 different types of complicated constraints. So this next one is a kind of an if then type of thing. So we're saying if you select number 4, then you also have to do number 2. And so let's see. So how do we do this? So if this is project 2, project 4, so you can do this, that's okay, right? If you select project, you can select project 2 and not project 4,
Right.
right? You can, if you select project 4, you have to do project 2. You can't do project 2 and not do, or sorry, project 4 and not do project 2.
No
Oops,
way, no.
what the hell? That's like your decision matrix.
This one a little trickier.
Yeah, I've not gotten that on my own.
But eventually, when you look at the formula, it's easier. So for some
Yeah.
reason, so
Yeah. You guess it? I don't think anybody guessed it in class, so don't feel bad.
No.
All right. So,
I actually looked up at Chegg. They gave like a
oh, did
really,
they do it?
yeah,
Chegg, oh man.
they gave a really good explanation to it.
Don't use
So-
Chegg. Don't use Chegg. I got a D+ on my test.
So it's like
Damn
project.
Chegg.
Yeah.
Project
check. It's
2.
great.
Project 2 value always has to be greater than or equal to project 4 value.
All right, so.
Project 4
yeah,
value can't exceed project 2 value.
Okay,
So here what we're saying is that project 2 value, so this equals this, oops,
F5.
has to be greater than or equal to project 4 value. So like, and you can test that out because if it says if 4 then 2,
Oh,
so like what if we
that's
said we did
why.
4 but we did not do 2? So do 1 here,
Oh.
0 there. So this is not satisfied.
What?
It's okay, buddy. You missed the lecture.
Dude, what?
Go to
Don't worry,
Almighty.
this is what everybody in the class was thinking, like, this is like next level Excel ninja shit.
That's
Yeah, I
how it
was
feels.
like-
I'm like, what the hell is this?
So I was actually thinking through this one in class. I use a different way of doing it. So I use the if function in
Solver?
B16.
Oh, in
no,
For
if function.
Uh-huh.
If I can share my screen. So
Did it work?
There's one.
yeah, it worked.
Huh.
Let me see. Screen 2. So can you see it? So I actually use a if function to
Mhm.
solve this. So see, like here I use so if this equals to 1, if
Oh, I see
f7
what you
equals to
did.
1,
Yeah.
and then if this equals to 1, then 1, 0. It's complicated thinking.
Yeah.
And then eventually this needs to be bigger or equal to 1.
Yeah.
So
You,
so
you
I-
basically wrote an if statement, a nested if statement that will
to kind of mimic
yeah,
this.
it'll
Yeah,
return
kinda
a
mimic
value
this.
that like solves that makes this mathematical.
But not
equation
until I see
satisfied.
that how he did it, and then I was like, oh yeah, huh, that's an easier way.
Yeah. I can't
So-
tell you how many times we've been in class and we're like going through an exercise and I do the same things like all right, I came up with a way to do it and he does his. I'm like, yeah, all right, that's easier.
Yeah. And then I use some if function to kind of try to get this number.
Oh,
Try
yeah.
to use like sum if, but it doesn't work with solver. So the sum if, count if
Mm.
doesn't work with solver. So you cannot use those functions.
Because it doesn't rerun the sum if when you run solver.
Yeah, maybe that's
Huh.
why. Mhm.
Okay.
But when I looked at this, I originally used some if for these two,
Yep.
and then just use the if function for these two, and then I figured this one it's easier to use just sum, like
Yeah.
how this is. But and then this one I couldn't turn the logic around. I was like, so it is when I look at the if 4 then 2, I automatically think of the if function and then just kind of try to work it out that way.
Yeah.
Yeah. Any case.
So
All right. So then
the way I did it, like
sure.
4 minus 2 should always be positive. Like
Oh, yeah,
should
yeah.
always be equal to 0. It cannot be -1.
Right. So it's equal to or greater than 0.
Yeah.
Yeah.
That's what I
Uh-huh,
did.
Yeah.
So
Yeah.
many roads lead to Rome.
It's dinner
Okay.
time. So they missed the most important part, the answer for the homework.
The answer for the homework. The homework that we haven't done yet, or that I haven't done yet.
No,
I just did it. So
Oh, you did it? Okay.
Yeah.
I just downloaded it.
But it's much easier than the class.
Yeah, I
exercise.
think there are just like 2 questions. So
Yeah. Mhm.
Oh, dang.
Oh, it's actually great. I mean, it's great to learn something new in Excel. I mean, I don't know
Oh,
if
yeah.
it's everybody. I don't know. Like some cohort may be against Excel, but I personally love Excel. That's
Me too.
that's the way.
oh no, me too. Like I like Excel very much.
It's
Yeah.
like, honestly, Excel is probably the single application I use more than anything else.
And I hate my company uses Google Sheets for everything.
Ugh.
Yeah.
I hate them so much.
All right, we good on that?
Yep.
So you just gotta make sure you add those extra constraints in now that you have them in your model. And then that's it. So questions 7 and 8 we didn't do. He said, don't worry about those.
All right. I'm
Oh,
gonna
wait.
call-
Hold on. Oh, actually, no, we're
Raoul.
good. We're good.
Good?
I good. Never mind.
Cool.
All right, Sid's gonna end this meeting.
What's that?
I
Oh,
said
you
I
gotta
need
end
to
it?
End the meeting because I have to eat dinner.
Ah, okay. All right.
Right.
Well, I haven't done the homework yet, so I'll do it. And well, Benny, you already did it. So I guess if anybody's got questions.
All right,